Welcome back to Space Repo, your portal to the cosmos. Today, we're venturing out to the gas giant Jupiter, but our destination isn't the planet itself. We're heading to one of its most enigmatic moons, a world that could be harboring the greatest discovery in human history. Beneath a thick, fractured shell of ice lies an ocean unlike any on Earth. This is Europa, and it might just be our best bet for finding life beyond our own world. At first glance, Europa seems like an inhospitable, frozen wasteland. It's a sphere of ice, slightly smaller than our own moon, crisscrossed with reddish-brown cracks and streaks that make it look like a cosmic marble. Its surface temperature plunges to a bone-chilling minus 160 degrees Celsius, a climate far too cold for liquid water to exist. Yet, appearances can be deceiving. Decades of data, from the Voyager and Galileo missions, have painted a picture of a dynamic and active world. The intricate network of lines scarring its surface isn't just for show, they are evidence of immense geological forces at work, hinting at something incredible hidden below. The true marvel of Europa lies beneath its icy crust. Scientists are now overwhelmingly confident that a vast, saltwater ocean sloshes around the moon's entire rocky interior. This isn't some small, isolated lake, it's a global ocean, estimated to be up to 100 kilometers deep. To put that into perspective, the deepest part of Earth's ocean, the Mariana Trench, is only about 11 kilometers deep. Europa's hidden sea is believed to contain more than twice the amount of liquid water found in all of Earth's oceans combined. An entire ocean world, locked away under a fortress of ice. How can a moon so far from the sun, in the frigid depths of the outer solar system, maintain a liquid ocean? The answer lies in its relationship with Jupiter. Europa is caught in a powerful gravitational dance with the gas giant and its other large moons. This constant push and pull creates immense tidal forces that stretch and squeeze Europa's interior. This process, known as tidal heating, generates enormous amounts of friction and energy, warming the moon from the inside out and keeping its subterranean ocean from freezing solid. This internal heat is the first key ingredient for life as we know it. But for an ecosystem to thrive, it needs more than just liquid water. It needs a source of chemical energy and a supply of essential elements. This is where things get even more exciting. The evidence suggests that Europa's ocean is not a sterile, static body of water. The reddish-brown material staining the cracks on its surface is thought to be salts and minerals, churned up from the ocean below and irradiated by Jupiter's intense magnetic field. This implies a direct connection between the surface and the seafloor. It suggests that the ocean is in contact with the moon's rocky mantle, a critical interaction. On Earth, this very interaction at the bottom of our oceans creates one of the most fascinating and bizarre ecosystems on the planet. Deep beneath our waves, where no sunlight can penetrate, life flourishes around hydrothermal vents. These are like underwater geysers, spewing superheated, mineral-rich water from the planet's interior. Instead of relying on sunlight for photosynthesis, organisms here use a process called chemosynthesis. They harness the chemical energy from compounds like hydrogen sulfide, which are abundant in these vents, to create food. Entire ecosystems of strange tube worms, ghostly fish, and hardy microbes thrive in this perpetual darkness, powered by the Earth's inner heat. Could a similar scenario be playing out in the deep, dark ocean of Europa? If its seafloor is geologically active, which the tidal heating strongly suggests, it could be dotted with hydrothermal vents. These vents would continuously pump chemical nutrients and energy into the ocean, providing the perfect ingredients for a self-sustaining ecosystem. Life on Europa wouldn't be basking in sunlight. It would be a life forged in darkness, powered by the moon's own internal energy. It might be microbial, clinging to rocks around these warm oases, or perhaps something more complex has had billions of years to evolve in this stable, protected environment. Another tantalizing piece of the puzzle is the phenomenon of cryovolcanism. In 2013, the Hubble Space Telescope captured what appeared to be plumes of water vapor erupting from Europa's southern hemisphere, shooting hundreds of kilometers into space. These aren't volcanoes of molten rock, but cryovolcanoes, geysers of water from the ocean below, bursting through temporary cracks in the ice shell. If these plumes are real, they are a direct line of sight into Europa's ocean. It's like the moon is actively offering up samples of its hidden sea for us to study. Imagine being able to analyze the contents of an alien ocean without ever having to land and drill through kilometers of solid ice. These plumes could contain dissolved salts, organic molecules, and maybe even microbial life, all ejected into space for a passing probe to collect. This incredible possibility has spurred one of NASA's most ambitious missions to date, the Europa Clipper. Scheduled to launch soon, this sophisticated probe isn't designed to land, but to make dozens of close flybys of the icy moon. The Clipper is a flying analytical laboratory, packed with a suite of 9 advanced instruments. It has ice-penetrating radar to map the thickness of the ice shell and confirm the depth and salinity of the ocean. It carries magnetometers to measure the ocean's properties by studying how it interacts with Jupiter's magnetic field. It also has high-resolution cameras to scout for active plumes and potential future landing sites. Most importantly, it's equipped with spectrometers capable of analyzing the composition of any plumes it might fly through. The Clipper will literally be able to sniff and taste the material erupting from Europa's ocean. The primary goal of the Europa Clipper isn't to find life directly. Its mission is to determine if Europa has the potential for life. It will assess the 3 key ingredients: liquid water, essential chemical elements, and a source of energy. By studying the ocean's depth, the ice shell's thickness, and the chemistry of the surface in any plumes, the Clipper will build the most detailed picture of this ocean world ever assembled. It will tell us whether the conditions are truly right for life to begin and survive. The search for life on Europa is about more than just finding alien microbes. It's a quest to answer one of the most profound questions we can ask: are we alone in the universe? For all of human history, life has been a singular phenomenon, confined to our own small, blue planet. Finding a second, independent origin of life within our own solar system would be a monumental discovery. It would suggest that life isn't a rare miracle, but a common, natural outcome of planetary processes. If life can arise twice in one solar system, then the universe must be teeming with it. Europa represents a paradigm shift in our search. For decades, we looked for life on worlds like Mars, focusing on past water and habitable conditions. Europa offers something different: a present-day, active environment that has likely been stable for billions of years, perfectly shielded from the harsh radiation of space. While the surface is a frozen desert, the ocean below is a protected sanctuary. It's an environment where life, once started, could have had an uninterrupted evolutionary path in the eternal darkness. The journey to Europa is a long one, but the potential reward is immeasurable. The data from the Europa Clipper will revolutionize our understanding of this icy moon and guide the next generation of missions, perhaps a lander that could one day drill through the ice and send a robotic submarine into that vast, unknown ocean. What wonders, and what forms of life, might be swimming in the dark, silent depths of Europa? We stand on the brink of finding out. The answers are waiting for us, locked away beneath the ice. Thank you for joining us on this journey to the moons of Jupiter. If you find these cosmic explorations as fascinating as we do, make sure to subscribe to Space Repo for more deep dives into the mysteries of our universe.